Okay, so this is section 10.2, and this is the first section on displaying data. There's two sections to this. Why they chose to split this one up into two sections and cram so much other stuff into other sections is beyond me, but we're going to roll with it. So we're going to look at how to visually illustrate data. Now, some of these things I expect that you probably have already seen before. Some of these may be new, though. So, first of all, data. So it can be categorical, numerical, or ordinal. Now, what does that mean? Categorical is just like the name implies. It's categories. So it's data represented in groups or categories, you know, like breed of dogs, makes of cars, things like that. You can have numerical data. Okay? Numerical data is, as it implies, numbers, right? And then there's ordinal data. That kind of combines the two. It takes categories and asks, survey participants to rate them on a scale. So, if you've ever had, like a how satisfied are you? You're like extremely satisfied, somewhat satisfied, neither satisfied nor dissatisfied, that kind of ranking. That's ordinal data. It has numbers assigned to it, but those numbers don't really mean the same as what numerical data numbers mean. All right, so the first type of graph we're going to discuss is a pictograph. This is probably one of the first types of graphs that kids are introduced to because it's pictures, right? Now, one thing about a pictograph is that it needs to have a legend. It needs to have something that tells you how much each picture is worth. Okay, that's going to explain a lot about the pictograph. Otherwise, you're going to have to make those assumptions, and those assumptions are not always good to make, especially when it comes to statistics. Pictographs are really good for just a quick visualization, as far as like, okay, how does this data look? Is this one group significantly bigger than the other one? So it's just really helpful for a visual. It's not good, though, when you start taking partials and, partial groups into consideration. Especially if you are using, say, tigers, like a picture of a tiger, and you have to represent 1/8 of a tiger. What does that look like? Is that like half a head and like 3 whiskers? What is that exactly? So that's where pictographs kind of fall short. So I went ahead and drew a pictograph to go with this scenario. So I've got days of the week and the number of minutes spent reading. So this would be a good pictograph for kids to be able to draw on their own. Looking at this, I chose to use a 5-minute increment to represent my little boxes here. Now just kind of, squint, tilt your head something, just pretend these are all the same size little boxes. These were going to be books, but my artistic ability is quite lacking, so we'll just pretend that they're books. So each one of these things represents 5 minutes. So Monday, 5, 10, 15, 20, 25 minutes spent reading. The 18 is tough because I've got 5, 10, 15, and then I've got a partial. So you can see this partial, it's hard to know, is that 2 minutes? Is that 3 minutes? Is that 2.5? Is that, how much is that exactly? But yeah, so there's a pictograph that you could draw to represent this data. So I want you guys to be able to draw a pictograph and to be able to read a pictograph off and tell me, approximately how much, these things are worth together. Next up is something called a dot plot, sometimes called a line plot. It's similar to a pictograph, but no numerical values are lost when we graph it. Another really cool thing about this is that gaps, clusters, and outliers are more apparent with these line plots. Now, what do I mean by that? Well, a gap is just that. It's a big gap in the data. A cluster is as it implies, a lot of data clustered, smushed together into one area. And outliers we will define more formally later, but an outlier is just kind of a point that's just kind of out on its own. It can be way up high away from the others or way down low away from the others. But we'll define it mathematically to determine just how far away, excuse me, just how far away it has to be in order to be considered an outlier. Okay, so I've already drawn a scale here. I went from 0 to 25 because the range here of my data is 0 to 25. 0 is my smallest point, 25 is my highest. Now what we're going to do is put either like a dot or you can put an X on each data point. Okay, so let's start. So we have 12, so 10, 11, 12. So I'm just going to put an X right there above 12. And I'm going to cross that off so that I know that I've already plotted that point. 5, I'm going to put that X right there. 7 goes right there. 3 goes right there. 0 goes right there. 2 right there. All right, now it gets interesting. We have another 0. So you stack those X's. I have 10, 12. I've got another 12, so I'm going to stack that X. 9. Ooh, we got a couple more zeros, so I'm going to go up a couple more. 15, 17, 25, 7, 8, 10. That's a duplicate, so I'm going to stack it. 12 is a duplicate. 13. Ooh, a couple more zeros. Oh wow, 3 more zeros. 1, 2, 3. I'm going to go ahead and cross off all 3 of those. We got a 10 and a 14. Alright, so my line plot looks like this. You can see that I've got, this point out here looks like an outlier. This space right here, what do you think that is? That'd be a gap. A cluster, you could consider this a cluster. Maybe, these could be a cluster. But this is definitely a gap. I'm pretty suspicious that that one's going to be an outlier. But yeah, that's all there is to, plotting these. So there's a line plot. All right, next up we got a stem and leaf plot. Now this is usually one that I bet you haven't heard of. This is a very, this is a not well-known kind of graph. This is similar to a line plot. Okay? It's just going up and down instead of side to side, and instead of X's, we're going to use the ones digits. Typically we use the tens digits over here for the stem and ones digits as leaves. Now, how you do these leaves, some books have you put commas in between them. Some books are very particular that you put them in order. I personally do not care. I think my lab does actually care and asks you to put the digits in order. Okay, but just to start off with, I'm not going to put them in order. So 97, the 9's right here, so that means my 7's going to go with that 9. That's the number 97. 63, so there's the 6. There's a leaf. 21, so there's my 20. 63, I'm going to come over here, got another 3. 52, 87, 82, 91, 73, 70, 81, 66, 92, and 89. So this is very similar to a line plot. We're just not putting X's. We're using the digits now. So I'm not 100% sure. I cannot remember because we also do this graphing in one of my other classes, and I know that that book requires them to put them in order. So let's just put a little note here. My lab may ask you to put the leaves in numerical order from least to greatest. I can't spell, and that's pretty sad. If that's the case, then you would just write 127, 1257 03 336 21. So just each little group of leaves, you may just have to put numerical order. Like I said, in some cases they ask for a comma, some they don't. I prefer a comma because I like that visual separation. That's just me. Okay. So, if you wanted to compare similar data, okay, so let's say that we have the test scores from, let's say you've got, I've got 2 sections of a class and I want to compare their test scores. Then I could do what's called a back-to-back stem and leaf plot. So I could do the leaves for one class, and then I could come over here and I could do, kind of another line over here and put the leaves for the other class over here. And that would kind of show me how they compared. That would be a back-to-back stem and leaf plot. Okay, so that one would have the leaves in here. Let me just say it was like 987, and you had like 3, 4, 4, 8, 1, 2, 0, 1, 1, 5. So if it looks something like that, and maybe over here it was like 0, 2, 3, 1, 1, 4, 9, and then 3, 6. That would be some. And now, where did this data come from? My butt. I just yanked it straight out of my butt. That's all. I'm just making up some data. So that's what a back-to-back stem and leaf plot would look like. Okay. Next up, frequency tables. So a frequency table is similar to a stem and leaf plot, except exact values are omitted and instead just a tally is kept. So we can have categorical frequency tables or grouped frequency tables. Okay? Your book only focuses on grouped frequency tables, which means that we're going to have these groups or these classes, as they're sometimes called. So here's my data. Okay, so here's my data points. We must first group the scores into intervals or classes. Now this is why we're using this grouped frequency table. We're going to group those scores into, well, groups for lack of a better word. Could you be any louder, dog? I swear I should have taken your collar off. There you go. Spin it out a few more times. Spin it out. There you go. Get tucked in. This is where she usually lets out a really big moo. No, just a big sigh. It's exhausting listening to me, I guess. Okay, so given the range of this data, I decided to make the classes of size 10 because it went from, what, like 21 all the way up to 97. So I opted to make, those intervals like that. Now, the intervals, it kind of depends on the amount of data and stuff. Typically, we want anywhere between like 7 to 10 intervals. Usually we don't want any fewer than 5. But so you'll find kind of conflicting stuff when it comes to this. Some books insist that, you always need 7 intervals no matter what. Some will say, oh, it's okay if you have 5 sometimes. Some will say, well, maybe you need more. Sometimes it depends on the data. Anyway, so let's look. Now, also, let me just point out something here. Notice how my groups do not overlap. So I go 90 to 99, 80 to 89. So look, notice I didn't go 80 to 90. Because if I put 80 to 90 right here, then where would the number 90 go? Would it go in this group or would it go in this group? You don't want to have any kind of overlap in there. You don't want any question as to which group it goes into. Your groups always need to be the same size as well. So you can't have one of them of group that's 10 and one of them is 9, one of them is 20. Okay, so I'm just going to keep a tally of how many are in each group. So let's see. I don't know if you guys could hear that creaky moo sound coming from my dog over there. I love her so much. So 97's in that interval. 63 is in that interval. 21. 63. So I'm just keeping a tally. So I'm just putting little tally marks. 52. 87. 82. 91. 73. 70. 81. 66. 92. 85. Now, kids start doing tally marks. Kindergarten, first grade, they start working on tally marks. So they're going to be really comfortable with those. All right, frequency. Well, there's 3, 4, 2, 3, 1, 0, 0, 1. Now, I don't know if you guys know, but when you do tally marks, you do 1, 2, 3, 4, and then 5 has a slash going across it to let you know it was a group of 5, and then you start another 1, 2, 3, 4 / 5. This tally mark also gives kids a visual representation for numbers, so that they can see this and say, okay, I know that's 3, instead of having to go 1, 2, 3 or 1, 2, 3, 4. If they see that slash, they know that's a group of 5. I forget what that's called. That has a name, where kids have that representation, where they can just like look at this and say that's 3 and not have to count. I forget what that's called, but that's got a name. So that helps teach kids that, that kind of number sense. Okay, now if we graph this with these intervals and this frequency, right? So we got this frequency table. If we graph the frequency table, that's called a histogram. Now, you may be thinking, oh, it's like a bar graph to me. You're not alone. This is often mistaken for a bar graph, but it is not a bar graph because bar graphs have spaces between the bars and are often used for categorical data. That's data that fits into categories, not so much intervals, not so much numerical data. Okay? Now, it's made up of adjacent bars, so they do touch each other. They do not overlap, but they do touch each other. The height of each bar is the frequency. So you'll see that interval from 20 to 29, see how I've got it at a height over here of 1? That's because that class, that interval, had a frequency of 1. Right here, 50 to 59, it's also at 1. 60 to 69, it's up here at 3. And so on. The bars should all touch each other. They should have equal width. Now, the reason they should have equal width is because these interval sizes are equal, and that represents the width. And the frequency, of course, is the height. Okay. Next up, bar graphs. So a bar graph is somewhat like a histogram, but it's typically used for categorical data. Like I said, categories, not numerical data. The bars have spaces between them, so that's usually your indicator as to the difference between histograms and bar graphs. So let's look at some categorical data, like the types of pets. Let's say that you do a survey in your classroom and you ask kids, hey, if you have a pet, what type of pet do you have? And we get this bar graph. So we have the bar graph is labeled as to the types of pets, and then this axis is labeled as well. Remember we talked about the misuse of statistics and how sometimes not labeling this axis can be misleading. So we've got, from reading this bar graph, we've got 8 kids that said they have a dog. We have 6 kids that have a cat, 2 kids that have a fish, and then what do you think this bird is about right here? We'll see how it's halfway between 0 and 2. So that's probably a safe bet to say that's 1, right? I doubt it's 3/4. I doubt anybody has 3/4 of a bird at home. If so, that kid's weird. You got 3/4 of a bird at home? Yeah. We could also compare data by using a double bar graph. So let's say that you wanted to compare the pets of a 3rd grade class and a 4th grade class. So you'll notice I put over here the solid was the 3rd grade class, and then the shaded is the 4th graders. So now you can compare, oh, okay, well, you know, the 3rd graders have more dogs as pets. The 4th graders have more cats as pets. You know, the 4th graders have more fish as pets. And then there's no birds in the 4th grade class. Yeah, so a double bar graph is exactly as the name implies, and it's 2 bars per group there. Now notice these are adjacent. These do not have a space between them. That's because they both represent dogs and because they are separate bars representing, you know, separate samples. Okay, and last up in this section is a circle graph, sometimes called a pie graph. These are useful when you're showing parts of a total. Okay, so they do use a circle. So let's use this data to draw a pie graph. All right, so I'm going to draw a circle, and you guys are all going to be polite and pretend that it's round. Okay, it's not the worst circle I've ever drawn. Now, what is our total here? I've got 10, 15, 16, 20. So my total there is 20. What we're going to need to do is figure out what percent each one of these represents so that we know how much of the circle to represent by that group. All right, so 10 out of 20. So let me just kind of come over here. So blue is 10 out of 20, which is what percent? Now, maybe you can see that one, right? That's just half. So that's 50%. If you divide 10 divided by 20, what are you going to get? You're going to get 0.5. That's the decimal. If you move that decimal point over 2 places, you're going to get that percent. So pink is 5 out of 20. Yellow is 1 out of 20. And red is 4 out of 20. All right, so 5 out of 20. 5 divided by 20 is 0.25, so that's 25%. 1 out of 20 is 0.05. Move that decimal over 2 places, and we get 5%. 4 out of 20 is 0.2. Move the decimal place over, you get 20%. You may have also got that by saying, well, if 1 out of 20 is 5%, 4 out of 20 must be 4 times the other one. So 5 times 4 is 20. All right, so that means half of my circle, right, half my circle here is going to be blue. All right. 25% of my circle is going to be pink. That's 1/4. So there's pink. What's left down here is going to be mostly red with a little bit of yellow. Now I'm not going to bust out a protractor here. But that looks pretty darn close, don't you think? I'm just going to color code this here for you. So we got blue. Do I have a pink? I don't know. I feel like I've got a pink. Just doing this for effect. Because apparently I have nothing better to do. Do I have pink? I'm over there digging around. Oh, hey, there's pink. So you're sitting there going, do I fast forward through all this? Nah. And red. I know I don't have a red highlighter, but that's cool, man. I got a red pen. Right. So what this means is we get this pie chart here that shows the favorite colors of a second grade class. Okay, takes this data and splits it up into pieces. Now this is another good visual when it comes to data, right? Because you can see, wow, okay, a lot of the class likes blue, right? You can see, hey, not a lot of people, their favorite color is yellow. You can kind of tell that immediately by looking at that visual. A lot of people mistakenly think that this 10 means it's 10% or 5 is 5%. No, because you got to take this out of the total. So when you take this part out of the total, that'll give you your percent. Okay, that'll give you a decimal, which then you can then convert to a percent. Okay, so that is the end of section 10.2. Section 10.3 is going to be more graphs, not as many, but yeah, so that finishes up 10.2 for us.